So here's the air inlet, sorry, outlet. So just goes through a little hole here in the. So this is the suction system just to clear away all the chips and dust and stuff that this makes. What this setup here does is just blows a high pressure blast into the channel you're cutting usually, and helps kick up all that dust so that the vacuum system can suck it up. Because I'm going to be cutting a deep piece of wood, or a deep cut on the wood, I really want this system working so I can evacuate all that dust, and that'll cool things down a bit and just be less pressure on everything. And I'll show you the solenoid valve next. So this is the solenoid, not connected to anything other than air, and the outlet going to the chuffer over there. So I'm just going to feed the cable through my little routing hole here. And figure out which connection I should hook it up to. So this is just the basic wiring loom for the controlling that solenoid valve. This is a solid state relay socket. This goes straight into the solenoid's terminal block. This is just a flyback diode. What that means is because it's powering an inductor, and the inductor, once you remove the power, you can get a voltage spike created in that inductor, and you don't necessarily want that travelling back to all your system. So what the diode does, it offers a short path so that that unwanted voltage spike can short itself out. I've already got a 12 volt power supply. This is another one, but I just want a sort of separate supply because when I had all this set up before and working previously before I changed over my machine, but before I had it running on the same power supply as everything else. Every time the solenoid kicked in, it would affect the signal going to the VDF, or the controller for the spindle motor, and the spindle motor would cycle in speed ever so slightly. So I'm just going to add a completely different power supply. I think the reason why it affected the spindle signal is because the spindle signal is literally a 0 to 12 volt coming from the power supply. So as you have a power draw spike to that solenoid, it's going to drop the voltage a little bit in the power supply, and that's going to lower your signal that controller sees. Anyway, I shall show you the next things I need to work on. The other thing I needed to sort out is the sacrificial base for the cut. I've already got the board, I've got the holes drilled out. I've just got to countersink these, because these screws that hold it in, I can't have them on the top because then they might get cut. I need them countersunk and sunk into the actual board by a few millimeters. But also these screws are a bit too long, they bottom out on these T-slot channels, so I've got to cut all these screws. And then I can use the T-nut system to properly mount this board. No, wrong way around. Anyway. All much shorter. Now I just have to clean the ends up on the angle grinder. Lovely smooth heads on them all. They need to be smooth because if I take this board on and off all the time, I don't want to be dealing with mutilated thread starters and stuff. Anyway, I shall countersink those holes and see if I can get it fitted. So the bit I use for countersinking, just one of these. I usually have a stopper, but I need to make a bigger stopper because I can't do these. You can do it by eye, but chances are with thin wood it'll just accidentally punch right through. There we go, we have one stop. Moment of truth. Ah, yes. So all I'm doing is wiggling these into place so that they're locked in with a T-slot. And this board is slightly warped, so it makes it a little bit more harder to get these things in. There we go. The screws are fairly well countersunk, and that board is not going anywhere. They're just wired up. Not much to say about it really, they're just a simple module you can get from eBay or whatever. And you provide 12 volts and then a signal using the same ground. And there's like a bunch of outputs on this. You can see output 1, 2, 3, 4. I wasn't using any of them before. So now I'm actually using one. It's a bit of a rat's nest in here, but it's all hidden. I don't have to deal with it. Anyway, the next step for me is to get the script side working on the computer. The brain, essentially, is what Mac call their scripting language, I think. Alright, I'm back again. So, I've remapped it. Instead of using output 1, I'm now using output 4, because under a spindle, output 1 is being used for the on signal, essentially, for the spindle's speed controller. So we've got this working again. So now I'll show you the basic of the brain. So I've just made a new brain. You put it in with the brain. Let's see if I still got this in. Yes, I have. So you got some default one in there. I've just put in a new one. So you click on the add input. So I'm going to use, I believe, the LED, and I'm looking for something related to the spindle on, right there. Now click on that. So this is just an input. So I want to do something else. So I don't want any comparisons right now because the output that produces is good as it is. So that's just giving a direct signal. Now this option here, I believe, terminates it. So what is my output going to be? So I want an actual output from the outputs pins, and I'm using output number 4 now, so I'll select that. So output number 4 should be whatever the spindle LED is. So if I save that and just make sure, yep, so that one's on. Just gonna, yep, so they're all reloaded, hopefully. So if I turn on the spindle, the air should come on. Yep. There we go, so that works. Now that's good if I want constant airflow, but I do not want constant airflow. I want to chuff it. I want it pulsed. So the next step is for me to figure out how to, where did my brain go? So instead of so I want a timer 0.25 seconds, and this time I won't hit enter by accident. So delay till repeat. So how long do I want it to delay? Maybe 1.5 seconds. Single shot. I'm not sure what single shot means. If second input, use it as reset timer. So now the output of when that signal goes high in that timer, I'm going to guess, is what I want my output to go high for. So if we save that, go to brain control, reload all. Now let's see. I don't hear anything clicking away. I just got a valve here to adjust the airflow. So my brain wasn't edited properly. Okay, after some further investigation I found out that this solid state relay indeed requires a alternating current to trigger. It'll trigger when you apply the DC current quickly, but if you have DC current constantly applied here, the solid state relay here won't engage. I just realized there's a forest growing out the gutter of the shelter. Been down to Jacars and I got myself a proper DC relay, solid state relay with all the proper ratings, 5 volt signal. and up to 2 amps current, which is hopeful. That's what the power supply is rated for, but it can be a spike in power when the solenoid kicks in. But I'm going to try and install this now. I've just wired this up. That polarity chart, it's a bit confusing, but like it's mirrored pretty much, but I got it working. I had a loose connection here in this bloody thing, so I'm gonna tape that up, I think. All these ants hovering around, they always come out at night. So there wasn't anything wrong with my timing as I was setting up in the brain. It's actually working. The problem is when the spindle turns on, for some reason there's a tiny bit of power that I think is keeping this solid state relay just energized enough so that the solenoid won't unlatch and return. So I've put a pull down resistor across the logic side of this in the hope that that'll pull it down, get rid of that extra power. Because this has a little indicator light on it that actually flashes in sync with my timing I've set up in the brain. I hate calling it brain, the script. But it's ever so slightly lit when it's meant to be off. And I can see when I turn off the spindle, it goes completely black instead of just slightly lit. And that's when the solenoid actually disengages. So I'm going to give this a try. So, it's now working. So, first thing I'm going to do is not actually cut anything. I'm just going to run a trial of the program in the air just to see how it goes. It's a completely untrusted program, I've never run it before. So this is what you should always do with a program, just to make sure everything runs fine. This is going to get a bit boring, so I'm going to just show you the computer screen, I guess. So the bits in light blue, you can see what it's already done. And it's just doing that second bottom plate or top, whichever one it is. looks like that finished pretty successfully. I didn't see anything too bad with it. I'm just going to repeat that with all the other steps, which is going to be very boring.